here we are in the Lisle School of Engineering in the Hillcrest Amphitheater. And I got three quick questions for you here. The first one is, suppose I put a plank on top of all the seats of the amphitheater, or right along one column of seats in the amphitheater. Suppose I put another plank on the steps of the amphitheater. And now I want to ask you, which has the steepest slope? The plank on the seats, the plank on the steps, or what about the handrail? We'll throw that in too. Which of those three has the greatest slope? I'll give you a minute to think about that. Okay, well, it's a little bit of a trick question because actually all three of those planks have exactly the same slope. How can we see that? Well, first of all, if we slid the plank on the seats over until it just touched the steps, we would see it would exactly match that contour of the steps. So those two have to be parallel, so they have the same slope. And furthermore, the handrail has the property that each one of the uprights of the handrail is the same distance. So we know the line of the handrail is always the same vertical distance from the steps, and we know that two lines that are always the same distance apart are parallel, so again, that has the same slope. So all of them have the same slope, and we could actually measure any one of the three to find out the slope of any of them. If I took out my tape measure and I measured the seats, I would find out that they're 36 inches deep and they rise 16 inches. So rise over run, that's a slope of 16 over 36, or we can reduce that to 4/9. We get the same thing on the steps, and this time we would measure them as 12 inches deep. And wait a second, now I don't even need to do the measurement because I know it's the same slope, so everything's in proportion. So if the depth, 12, is 1/3 the depth of the seats, that was 36, then the height of each step has to be 1/3 of the height of each of the seats, that was 16 inches. So we automatically know that the height of each step is 1/3 of 16, or 5 1/3 inches, and you could verify that with a tape measure and see it comes out exact because it's math. Second question I've got for you is, this is an amphitheater, so each one of the seats is an arc of a circle. What fraction of a circle is each one of those arcs? Again, I'll give you a minute to think about it. Okay, well, how could we attack this problem to try to figure out what angle, what percentage of a circle each one of these arcs is? And, well, we want to look at their endpoints, right? Because that's what delineates how much of a circle it is. And we'll see that those endpoints are the two walls of the building. There's a wall over there, and there's a wall behind me. And if we look at the structure of the building, well, those two walls don't quite meet, but you can tell from the outline of the building that even though there's a wall in between that's at an angle to both of them, those two walls are perpendicular, and so they're going to meet at a right angle, and that's the angle of these arcs. It's 90 degrees, 1/4 of a circle. So this particular amphitheater is 1/4 of a circle. And that third question I've got for you is, we said that each one of these rows of seats is a circular arc. That means there's a unique point where if you're standing to speak, to address the crowd here in the amphitheater, you'll be at a point where everybody in the same row is equally distant from you. Can you find that point here in the amphitheater? Take a look. Again, I'll give you a minute to think about it. Okay, so the question was, where is the center of this amphitheater? The center of the circle, of which its rows of seats are circular arcs. That's the point at which everybody in the same row is equidistant from you. We want to find that center. Well, it turns out this is a little bit of a trick question. If you think about it, the center of a circle has to be at the intersection of any two of its radiuses, or radii, as we sometimes say. So we want to find the intersection of two radii. Well, we just said that the ends of these arcs were the two walls of the building, and so those two walls have to be radii of these circles. So where those two walls meet, that's the center of the amphitheater. But remember, we said the two walls don't actually meet. They're intersected by another wall that's at angles of both of them. So the actual center of this amphitheater, as you can see from this diagram I've got right here, is inside the building. So you extend this wall extend that wall until they meet. If you were actually addressing the audience at the center of this auditorium, you would be addressing them from inside of the building, so they wouldn't actually hear you very well.